Hello, welcome to another episode of Baz Codes. I'm your host, Bob, and yeah, maybe. And today I'm going to show you some work I've been doing on the GSSquared Apple II emulator, specifically a little UI polish, just experimenting with some ideas, and on the debugger, where I've made quite significant progress. So without further ado, let's get started. As you may remember, um, the debugger um, shows a live system trace. It stores up to 100,000 entries, and then it rolls over. It just keeps writing over itself. There's limited RAM, and a million cycles per second emulated, uh, several 100,000 to 500,000 instructions per second. There's limits to what you can reasonably record, but 100,000, especially when combined with breakpoints, which I'll show you here momentarily, is a pretty good buffer to help you diagnose and troubleshoot and debug stuff. I've actually been using it to diagnose and kind of investigate issues that I've seen with certain software that doesn't seem to want to work right on my emulator. So it's actually proving to be very helpful already. So first off, we've got a couple of minor changes and improvements here. When I run the mouse over, here's some UI stuff. When I run the mouse over, you'll see this little triangle box pops up. That's now a mouse-driven way to open the on-screen display control panel. You'll notice the fonts are nicer now throughout the system. I finally got the TrueType font library integrated, and I'm loading different fonts here. Looks amazing how much difference just a little font change will make to a design. So there's that. And of course, you go over here and, oops, you can close it with the same thing. So, it just kind of wiggles back and forth. I kind of like that. Nice and simple. I think I'm going to move some of this stuff to here and have it, fade out just like that does, right? If you're just typing, and this is an 8-bit computer, right? They came out with the mouse at some point, but there's not that much software that uses the mouse. And so when you're working on these things, you're doing a lot. It's a keyboard. So, also if you capture the mouse by clicking in it, then it doesn't trigger the menu again. By the way, you may have noticed when I clicked to capture the mouse, it says mouse captured, release with F1. So I've got this mechanism now for displaying little messages like that. There's a couple of other messages I put in the system when you change the screen display engine, which is how I render video stuff. You'll see here, I'm using a key press to change it. So this is NTSC, RGB, monochrome. And then, that doesn't make a difference yet. But anyway, so that's that. I figure there will be a variety of useful things to temporarily display to the user. I want, kind of this uncluttered experience. A lot of the other emulators that are out there, I think kind of interfere with the proper nostalgia by cluttering up the window with all kinds of stuff. Controls in a window. It's like, it's like taking you out of the movie, right? It's when the movie does something so ridiculous that you come back to reality. In this case, I like to be able to hit full screen, and it's just like I'm sitting in front of an Apple II, and there's nothing bothering me. But at the same time, I want to have the controls, right? I need to be able to put disk images in and whatnot. So this, I think this is a happy medium, and, it fades out. The modern era dissolves, and we're back in the 1970s here. All right. So, and there's one more. When we've got the gamepads here, these things, like this one goes to sleep. So when you hit the start button to start it, it boots up, connects via Bluetooth. You'll see it said gamepad connected there. And so if I were to disconnect it, or if it were to go to sleep, it would say, gamepad disconnected. So that's also useful diagnostic, I think, for folks. It's like, because I usually forget to turn this on until after I've started Choplifter. And I like to get that little feedback that it's working properly before I, start the game. All right, so moving on to debugger features. So a little reminder here. So this is the trace screen. You'll see it says trace right there. And what we've got here is the current register values and the program counter, cycle counter, current effective megahertz as we zoom on by. Now, in this display, if I hit space, execution stops. You'll see my megahertz is dropping. It'll drop to 0 here because we're executing no instructions. This is essentially if we were to stop toggling the clock going into a real 6502 chip, then this is sort of what would happen. Or if we hold, I think there's actually a signal on the 6502 to freeze execution. Tell me what it is, if you know what it is, in the comments. So anyway, we're sitting here in a keyboard loop, of course, reading C000, and unless we've hit a key, it just keeps going back and forth. 4E and 4F are 2 bytes involved in pseudo-random number generation. So as part of the Apple II ROM, whenever it's waiting for a keyboard input, as part of the ROM routine, if you do it yourself, this doesn't apply. But if you're using the ROM routine to read a character, it's constantly incrementing these 0-page memory locations. And if you're a programmer, you can read them to get what's essentially a pseudo-random number, as long as there's been a key press. So that's what that's doing. I'll show you a little experiment, or a little demonstration with that later. So, right, I can single step through these instructions, and if I hit enter, we go back to, full execution mode. Great. So now let's say I wanted to look at that memory, right? Well, how do I look at memory stuff? Memory locations, as they're changed, quite rapidly here. So I implemented a monitor. I thought, this interface is something that every Apple II aficionado probably knows about the monitor. Now, I decided not to implement the Apple II monitor commands exactly. I wanted a little more flexibility. I've got a couple of shortcut commands that are Apple II-ish, or more like the Apple II way of doing it, just because. But, I thought rather than build some excruciatingly comprehensive GUI, user interface, let's just use a command line. So when I click into the command box here, it defaults to help, to tell you, hit help if you want to see what this thing can do. So we've got the commands watch, which is managing what memory ranges you want to watch. BP for breakpoints, and that's execution breakpoints, and those will trigger on both the program counter as well as memory locations read or written. Sorry, just a moment. I don't know if you saw the cat there. All right. The cat always insinuates itself into my videos or tries. Nice try. Okay. Set. So you can set memory to values. You can look at memory values. You can load, save files from your host computer in and out of emulated memory. Yeah, there she goes. Okay. She's rather indignant about being removed. Um, and memory move command. So let's say we wanted to watch what these, 4E and 4F addresses are doing. So we're just going to do watch 4E.4F. This is the same format that the Apple II monitor uses for memory ranges, right? Address.address. So hit that, and there we go. We're now monitoring live, right? Those memory addresses. I can do other stuff here too, like, what would be something interesting? Well, why don't we do the first line of memory here, or the screen. There's the first line of the screen. And if we go up here, you'll see I'm typing stuff on the screen, and we have it appearing there. I'm using of course, the memory dump, sort of normal memory dump format for an Apple II that the monitor would do, except I'm doing 16 bytes wide instead of just 8. And, well, there's that. So that's cool, right? Now, what if I want to do, change memory? So I'm looking at memory. Well, I can also just look at memory in here, right? So if I just do 400.428, again, just like the monitor, boom, I've got it displayed here. So this is a little more interactive. The memory watch, automatically updates every cycle or every screen refresh. And if you're doing instruction at a time, then it will, right? It'll update all the memory locations. So you can see, memory values changing in context as you single step through a program. So we can do that. We can also, of course, we can also modify memory addresses here, and we can use both, set 400 to those and succeeding to those values. Oh, look, I made those characters inverse, right? Because I use the high bit not set. Or we can also do the Apple II version, or the Apple II notation. There we go. I made them flash by setting the bit 6 in those characters. Right. Of course, this works with I/O locations too, right? So, let me put that back on color. So I can change the text page, right? Just by typing those soft switch addresses and read, right? CO50 goes to graphics mode. I currently have low res selected. Let's see, what is it for high res? I think that's it. It must just not have anything in it. Well, let's put something in it. There we go. Yeah. So I put some stuff in the high res page there. If we want to, you can use the move command, and you can be tricksy about it like the Apple II did. So let's see. We're going to move 2000 to 3FFE to 2002. That should repeat a bunch of stuff. That didn't work. Maybe this doesn't work. Maybe I haven't implemented this yet. I'm not sure. Oops. Yeah, I thought I did. Well, anyway, you get the idea, right? You can fill memory quite easily using the move command, and clever. That should put 2000 in 2001 and then repeat. Yeah, it's not working. I didn't implement it, or something's wrong with it. Okay, well, let's pretend that worked. Let's just pretend that works, and we'll have known all about it when I put it on the GitHub issues page. All right. So we did that. Breakpoints. Right. Okay. Well, what if we were to see, we've got a very tight loop going on here. Let's put text back on. We've got a very tight loop here. So I've got stuff. Let's say we want to trigger on whenever we're accessing the keyboard. So I can create a breakpoint by just putting in a range. So C000, I think it is, right? To C000. So I'm just going to do a 1 byte breakpoint range. So when I enter that breakpoint, oh, you'll see our execution stopped right after the instruction where we accessed the keyboard register, C000. Now, when you have the breakpoint set, you hit enter to resume, and it will then, you'll see we're going a few instructions at a time here because it starts running full speed and then it stops at the next breakpoint. You can just type BP to list the current breakpoints. Let's say I was going to type in some, how do I want to do this? Some AppleSoft stuff. I know, let's do a breakpoint on modifying a screen location. So I'm going to say breakpoint 400 to 428. Let's say something changes the top line of the screen. All right. So we've got that. I'm going to remove that first breakpoint, and that's just no BP. And there you just put the first address to remove it. Right? Okay. By the way, this does have command scroll back, right? So you can just, or command history, you can just up arrow to go back to previous commands. Okay, so I've got that. Oh, let's resume execution. And let's do, up here, let's do a home. Now that's going to clear the screen, it's going to go try to write, a space or a blank to address 400. Boom. There we go. So here's our here's our instruction down here. They're using a 0-page indirect indexed, I think it's called. And we did, in fact, write a space, A0, right, into memory location 400, which is the first character of the display here. Right. So that's how you breakpoint on a memory access, or you can breakpoint on, an instruction access. So what's that instruction? FCA0? Okay. 0 point. Let's just do that one instruction. And let's say no BP 400. Let's resume. Oh, it's going to immediately freeze again because there's that, right? So I can go, one loop execution of the loop at a time here. That's great. Okay, so I'm going to say no BP FCA0. Let's resume it. Okay, great. So I think you get the idea there. I've got memory watch, and we've got the ability to breakpoint. Let's see, what other commands did we have here? Oh yeah, load. Load file name and to an address. Let's definitely do that. So I've got, let's just HGR here. Now, I'm not running DOS or ProDOS, right? It's not loaded. I just booted the thing, hit reset. However, we have high res on, and I can do, let's see, load. Let's hope I'm in the right directory. /decode/iRes/Apple. So this is going to load the contents of that file off of my, my Mac disk into address, starting at address 2000. And there you go. This has got all sorts of other handy, cool little pictures. Actually, there's like, I don't know, 150 pictures in there or something. But so this shows load, local file into memory. Now, of course, it doesn't have to be a picture. It can be anything. It can be a program, what have you. And you can save out the same, right? I won't show that, but you can do, save file name, 2000 to 3FFF would save the contents of the high-res page to file name. There you go. So let's see. Did I cover everything? Load address setting. Yeah, I think so. So anyway, that's where I'm at with this debugger function for this. It's like I said, it's proven pretty helpful to me already for finding tracing execution of programs that don't seem to be working right and being able to patch around them. As an example, I was having trouble with rescue raiders, and came to realize pretty quickly that rescue raiders was crashing because it saw that there was a mockingbird in the emulator, but I don't have the speech synthesis implemented. But yet, for some reason, it thinks that there's a speech chip on it. So it goes off and does the speech stuff and then is waiting for an interrupt from the speech chip to say that it's done and ready for the next phoneme. So it was just, it was just dying. So I was able to just, with the monitor here, patch those bytes and just have it skip, that routine. And that was helpful. There was another game, Apple Cider Spider, that was clearing the joystick strobe through a store instruction as opposed to a load, which I wasn't handling. And I was able to, pop in the debugger, trace the execution, what's it stuck on? Okay, let's do let's look for CO70, access it to CO70. And boom, immediately it popped up and said, oh, it's an STA, CO70. So it's like, okay. I found and fixed that problem very quickly, 100 times faster than if I, just have to guess through. And certainly light years better than the original approach in this of lots and lots of printf debugging, which of course is just a nightmare to deal with. Anyway, there you have it. If this is interesting, click like and subscribe so you'll get more of this next time. You can follow my progress. And if you don't, go click on a Britney Spears video or something if you're that kind of a person. All right, I'm kidding. Bye.